this video, we're going to look at apparent and true depth problems. So firstly, let's set up a scenario. So I've got two symmetrical beams which are reflected off a coin on the bottom of a pool. One beam emerges, so it makes an angle of 20 degrees with the normal, and the image is formed 1.2 meters deep, where water is 1.33, and we're looking at it from above. So the first question asks us to draw a sketch of how the image is actually developed. How do we see that image? So let's draw a diagram. So what I'm going to do, I'm going to use a horizontal straight line to look at my boundary and separate air from water and label them. Okay, so there's my air and there's my water. Right, next thing, I'm just going to put a quick sketch of the coin. That's sitting on the pool. Great. Okay, so the beam is emerging from a specific point. So I'm going to put a normal line in, and there's my point. Now, it says the two beams are symmetrical. So they leave an angle of incidence of 20 degrees. So when it hits the boundary surface, it's also going to make 20 degrees. There's my refracted ray, which we'll explore later. Now, as I said, it's symmetrical, so another beam will come off at the opposite, in the opposite direction, but still at 20 degrees. Okay, so then it's refracted away. And they don't converge on the air side, so they converge as a virtual image on the water side, and where the two lines cross and track back, there's my image. That's where I see it. So I'm looking from above, and I see that that image is 1.2 meters deep. Excellent, so there's my sketch. Okay, so let's look at question B. So in question B, it's going to ask us how to determine the refractive angle of the light beam as it emerges from the water. So let's write down what I know. Well, I know the refractive index of water is 1.33. I know the incident angle is 20 degrees. The refractive index of air is 1, and I've got to find the angle of refraction. So there's Snell's law. Now, N1 is going to equal the water, because that's where I'm coming from. N2 is going into the air, which is the second media. N1 is going to be theta I, and theta 2 is going to be theta R. So we substitute in, so we get 1.33 sine 20 equals 1 times sine theta 2. So sine theta 2, just moving it over to the other side, equals that. And theta 2 is going to be the inverse sine of 1.33 times sine 20. So I get that the refractive angle is 27 degrees. Okay, let's look at question C. So question C is going to ask us to calculate the depth of the pool. Now, we know that the refractive index equals the real depth divided by the apparent depth. And I know that the refractive index of water is 1.33. I know the apparent depth is 1.2 meters. So I just rearrange so that I bring apparent depth up with the refractive index. So it's 1.33 times 1.2, which equals 1.6 meters. Thanks for watching.